Unit 5, we are dealing solely with exponents and roots. So in order of operations, our second step is exponents. Today we're going to, or in this unit, we're looking specifically at different types of exponents and what exponents do and what they mean, okay? So 5.1, we are just learning about what exponents mean, and we are going to do what we call expanding them. So what do you think expanding something means? And we're making it bigger, okay? So very first thing, let's get a definition. What is the definition of an exponent? An exponent, what is the exponent here? In this example, x to the third. Is x the exponent or is 3 the exponent? X is called a what? X is a variable. 3 is the exponent. Good. What does the exponent tell us? The exponent tells us how many times, and this was a typo. How? I typed it wrong.
There was a typo in science question.
Yeah. The exponent tells you how many times you multiply that term by itself. So if I have x to the third and I want to expand that, how would I expand it? X times x times x. So we are multiplying x by itself 3 times, just like the exponent told us to. Now we're going straight to example 1. That's it. Yeah. So example 1, x squared y to the third. So your instructions on your homework are going to be to expand this. So how can we expand this whole thing? We have an x squared and we have a y to the third. So we would expand x squared to be x times x times y to the third, y times y times y. And that would be your answer.
Oh my God.
Good question. We have 2 special names for exponents. The first one is squared. If we say something is being squared, what's the exponent there?
2.
Yeah, it would be like x to the second power. Okay, the other special term is cubed. Connor knows this, but does anybody else know? What is the exponent in cubed, Cameron? 3. We would call this x cubed. Okay, what about x to the fourth? Is there a special name for that one?
No.
No, we would just call it power of 4, fourth power, or x to the fourth.
Why can't we just call it quad?
Okay, so and so on all the way down. We do not call it x4, x6, x7, because those are something totally different that you will use later on in math when you get to high school. Okay, so we need to make sure that we start with good habits now, and we put that th at the end when we're talking about exponents. Okay? X to the fourth, or x to the sixth. Okay? Example 2 asks us to expand x, y to the fourth.
So if there's like no exponent to x, is it with y? Or?
If there is no exponent attached to the x, how many times we number?
4.
Just the 1 time. So if there is an exponent, it's like there's an exponent of 1 up there. You just can't see it. You know how our 1s are invisible sometimes? Same thing. Okay, and sign out. Up there. So what would this be? This would be x times y times y times y times y. Good. Okay, example 3. This one's a little bit different. Now, one thing we have to know about exponents is, you guys remember how I tell you that if we have something like x minus 3, and that 3 is actually a what? It's a -3 because the negative sign is super glued to the 3. It's the same thing with exponents. The exponent is super glued to whatever is directly in front of it. So what is that squared super glued to? Is it? What's directly in front of it? The parentheses. So what's actually being squared here? The everything inside the parentheses, right? So how would we rewrite this as an expansion? S divided by T times
X divided by T.
S divided by T.
Wait. What up?
And what if I had something that looked like this? Now what's that exponent attached to? The S. So how would we expand this one? We would do S times S, all of that over T. So it's whatever the exponent is attached to, that's what we have to expand. So let's try example 4. This time they give it to us in words. H cubed. How do I write H cubed? Cubed means to the exponent of what? 3. So let's first rewrite it as H to the power of 3, or third power, same thing. And then how would this expand? H times H times H. Okay, let's do something a little bit different. 5 squared. Example 5. How do I expand 5 squared? Excellent. 5 times 5. Now, on this problem, exactly. Rolando has it right on the nose. He said, can't we multiply that? Yes, we can. What is 5 times 5?
25.
So I can actually simplify that even more and multiply 5 times 5 to give me 25. Okay, example 6. 2 to the power of 6. Let's expand that first. What does that expand to?
2 times 2 times 2 times 2 times 2 times. No.
Times 2.
5.
You only said 5. Okay. So what is 2 times itself 6 times?
64.
Good job. You know how many people thought in first period that it was 16 or 12?
Oh my God. They already know.
Because they went straight to 12, multiplying 2 times 6. They didn't do it all the way out. So let's do it. 2 times 2 gives me 4. 2 times 2 gives me 4. And 2 times 2? 4. 4 times 4?
16.
Times 4?
64.
Mm-hmm.
We're smart girls.
Good job, you guys. Good job. Example 7. I need everyone's attention for example 7. This is a very commonly missed type of problem, even in Algebra 1 and Algebra 2.
It's like a very common one.
Okay? -2, all of that squared, or all of that to the 4th. Let's expand this first. What is the 4 attached to? Is it attached to the 2, the negative, or the parentheses? It's attached to the parentheses, so let's expand this. -2 times -2 times -2 times -2. Let's take a poll really quick. Raise your hand if you think my answer will be positive.
Me.
Raise your hand if you think my answer will be negative. Okay, let's see who's right. What is -2 times -2? Positive 4. -2 times -2? And what is positive 4 times positive 4? Positive 16.
I was right.
Question for you. Here's your new problem. What do I do there? Is that the same or different? They are different. How is this different? What is the 4 attached to? The 2 only, right? Only the 2, not the negative. So what do we have? -2 times 2 times 2 times 2. You guys are so smart. So what's that going to give me? Negative 16.
Okay.
So if there is parentheses, my answer is going to be positive. If there's not parentheses, my answer is going to be negative. This is very commonly mixed up. So just pay attention to what the exponent is actually attached to. Okay? Okay. Example 8. Home stretch. We have x squared, and now we want to evaluate it if x equals positive 8. So what we are going to do here, the first thing we're going to do is expand. So how does x squared expand? X times x. And we want to plug in what for x? 8. So let's plug it in. Whenever we plug in, what do we put around the number? Parentheses. So this is the same as 8 times 8. And what is 8 times 8? 64. Okay? Example 9. Try example 9 by yourselves, please. M squared if m equals negative 5. M squared expands to what? Good. M times m. Okay, and then what do I want to do next? Nika, what do I want to do next? How did you get that, Phil? Good. So we substituted negative 5 in for m. And negative 5 times negative 5? Positive 25. Excellent. Okay. Example 10. This is something a little bit different than we've seen before. Now we have a number being multiplied by the x squared. So we have 8 times x squared, and we want to expand this. Does anyone have any ideas how I would expand this, Robert?
8 times 6 times 6.
Well, we haven't plugged in the 6 yet. 8 times x times x. Good. So that 8 is just being multiplied by the x, so we just can expand the x squared. Okay, now what am I going to do, Josh?
You plug in 6 for x.
Yep, I plug in 6 for x. Good. So 8 times 6 times 6. And what is 8 times 6?
48.
48 times 6 gives me a big number. 288. Okay? How does it expand? 5 times a times k times k times k. Good.
And then the negative 2.
Yes, I plug in negative 2 for k.
Did I call it for her?
5 times negative 2, what does that give me?
Negative 10.
Okay. Negative 10 times negative 2?
Positive 20.
Positive 20 times negative 2 times negative 2? Negative 40. And negative 40 times negative 2? Positive 80. Good job.